Right now, Tabby Star is still dimming, and NASA has no way to stop it. Not fading slowly the way old stars do. Not flickering on a schedule anyone can predict. Just darkening, randomly, dramatically. And the best minds at NASA, Harvard, and Caltech are watching it happen in real time with zero explanation. But here's what nobody is telling you. This star doesn't just break the rules. It breaks them in a way that makes scientists genuinely afraid to say what they think. KIC 8,462,852. That's its official designation. Most people know it as Tabby Star, named after astronomer Tabitha Bayagian, who first flagged it in 2015 as something that simply should not exist. It sits about 1,400 light-years from Earth in the constellation Cygnus. A mature, middle-aged star, bigger than our Sun, stable, the kind of star you look at and expect to behave. But when scientists pulled data from the Kepler Space Telescope, they found something wrong. This star was dimming, not by the fraction of a percent you'd expect from a passing planet, by up to 22%, in irregular bursts. No pattern, no warning, no physical explanation that fit. Every time astronomers thought they had an answer, Tabby Star proved them wrong again. Here's why that matters. When a planet crosses in front of a star, you get a clean, predictable brightness drop. 1 or 2%. It recovers on a fixed schedule every single orbit. Tabby Star drops by up to 22%. That would require an object larger than Jupiter crossing its face. But the dips don't repeat on any schedule. They come in clusters, go quiet for months, then return harder than before. And the shapes are wrong, asymmetric, jagged. Some look like a smooth bell curve. Others look like a comb with uneven teeth. No known planet produces that pattern. No known natural object in the universe produces that pattern. The Kepler data doesn't show something unusual. It shows something our entire model of stellar physics has no category for. And that worried them even more than the numbers did. So scientists landed on dust. A cloud of debris drifting across the star, it would explain the irregular shapes, the asymmetry, the jagged light curves. They ran the numbers. Dust absorbs more blue light than red, so the star should look redder as it dims. It does partially, but not enough. Dust accounts for some of what we observe, not all of it, not the long-term trend, because the full archive told a different story entirely. Tabby Star isn't just dimming in random short bursts. It has been getting steadily, consistently darker for more than a century. Photographic plates from the 1890s, observatory archives from the 1980s, Kepler data from the 2010s, all trending the same direction. This star has been slowly losing brightness for over 130 years. Dust doesn't do that. No natural process we understand does that. And that is where the standard explanations stop. Because here is the part they are afraid to say out loud. There is one structure, theoretical, hypothetical, but mathematically consistent, that explains every single anomaly at once. A Dyson swarm. A field of megastructures placed around a star to harvest its energy. Not science fiction. A concept proposed by physicist Freeman Dyson in 1960 as the logical endpoint of any civilization that outgrows its home planet. If you place thousands of large collectors in irregular orbits around a star, different shapes, different sizes, different orbital periods, you would produce exactly this signature. Asymmetric dips. Irregular light curves with no repeating period, and slow, long-term dimming as more structures are assembled and cover more of the star's face. The math fits. Every other hypothesis leaves at least one data point it cannot account for. The megastructure hypothesis accounts for all of them. NASA hasn't ruled it out. Caltech hasn't ruled it out. In 2016, a paper in the Astrophysical Journal explicitly noted the data is consistent with artificial construction. That was 10 years ago. Tabby Star is still dimming. Right now, today. Think about what that means. We have pointed our most advanced telescopes at a single star 1,400 light-years away. We have collected decades of data. We have tested every natural explanation against the physics. And we are still standing here without an answer that closes the case. Either there is a natural phenomenon happening around Tabby Star that we have never seen, never predicted, and cannot currently model, which means stellar physics has a blind spot large enough to hide something this dramatic, or something built it, something that required energy on a civilizational scale, something that has been operating long enough to dim a star across 130 years of recorded human observation. Both of those answers rewrite what we thought we knew. One tells us the cosmos has processes no textbook has described. The other tells us we are not alone, and whatever is out there started building long before we had electricity. So here is the question no one can answer. If it's natural, what is it? And if it's not, what does it need all that energy for, and does it know we're watching? The data keeps coming in. The star keeps dimming. Whatever is happening out there is still happening right now while you watch this. Drop your theory in the comments, because the scientists certainly don't have one.